All right, our special guest today, Dr. Toby, Engineering Manager for DB2 PureScale at the IBM Development Lab, Toronto. Toby will be sharing invaluable insights on the DB2 PureScale 12.1 feature with focus on its integration with Pacemaker and CoreSync.
Yep, I'm just going through some fun trying to get myself hooked into the meeting. So just bear with me and we will see where we get to.
Please give us about a couple of minutes. We have technical difficulty with the webinar link, which is not working on Linux. We're working through the alternative.
Okay, I can now see the screen.
Oh, great. Awesome.
I'm on the phone, so Moen and I are going to be basically doing a double act here, so we'll have to see how we go.
Sure. Yeah, thanks, Toby, for joining us today. We really appreciate you taking time to share your, the expertise on DB2 PureScale, and it's always a privilege to work directly from the development lab, and we are looking forward to learn a lot from you today.
Yep. So let's get started.
Sure. We are getting involved. So please do follow us on Twitter, X, and then DB2Night Show on YouTube. You will see all the pre-recorded videos of the replays from our blog as well as from YouTube. Join us on LinkedIn. Here's a link to join. Disclaimer, right? Tonight's show, as we know, it's DB2Night Show episode 268. DB2 PureScale with Pacemaker on Linux. Please do post your questions in the chat. If you have anything, we can discuss at the end, right? This is an opportunity for you to talk directly with Toby and then get the insights on PureScale. Any questions on PureScale? Any questions on DB2? Upcoming sessions, we have PureScale in Hyperscaler. It's going to be in Azure and AWS. Online index VR for PureScale, and then we'll have some DB2 internal sessions. Right, DB2 DBI software now supports SQL Server along with DB2, so you can find all the products which are supported on dbisoftware.com website. Please do visit and look at the demo to see the performance benefit you're going to gain from the product. Right, we'll have a couple of questions coming on your screen. I'm going to send the polling questions for you. Right, you will see the very first one about DB2 version you're using. Give it 30 seconds to answer the polling questions. Awesome. We're collecting the responses. Right, closing the poll, sharing the results. Pretty good, about 78% on 11.5.8 and higher, 22% on 11.5 and 11.1, 11%. Good that we don't have anybody on 10.5 and 9.7 and older.
Thank you.
Are you planning to upgrade your database to 12.1? If you need to know more about the DB2 12.1 features, Mike from Lab provided a lot of insights into what is supported, what is available with the 12.1 features, or in the previous DB2Night Show session. You can go and watch it. All right, collecting the responses. All right, we're gonna close the poll and sharing the results. Good, 78% and 33% wants to understand more about 12.1. That's why we are here. And then please do visit the previous webinar to look at the 12.1 features in broader sense. What are your environment challenges for DB2? right, audience are providing the responses. We have pretty good response in place. All right, we're going to close the poll and share the results. 43% performance, 43% availability. That's where we are at this point now, pureScale, and 14% on data growth. Are you running HADR with Pacemaker in production? Wow, pretty good response. Collecting the responses, closing the poll, sharing the results. Only 14% on Pacemaker, 57% on PSA, and 29% they're still working through. They're currently on a standalone. Relevant question for this session today. Are you running DB2 pureScale? All right, good responses. Collecting the responses now, closing the poll, sharing the results. 56% are using pureScale and 44% no. Good chance to implement the pureScale feature. All right. With that, we're gonna go to the next slide. Toby, thank you. I'm gonna start presenting the DB2 slides. I'm gonna go back to my slide deck here. Let me know when I see it.
Looks good.
Toby, all yours.
As long as you can hear me, we're all good to go.
Yes, I can hear you well. Pretty good.
Okay, let's get into this. So we've been working with Pacemaker in the sort of DB2 development area. This is to us. It debuted in 11.5.4 as really a sort of technical preview of what we were going to do with HADR, and it's developed from there. So anyway, let's get into pureScale. The slides fairly quickly. The next one is going to be disclaimers. Yep. And the next one is also disclaimers. There we go. And now we can get into the agenda. Good. Okay. Excellent. So we're going to start by just having a quick look at a history of DB2 pureScale. And then we're going to sort of get into the details about what you're going to see, what's new, what looks familiar, what's gone away as we get into the sort of DB2 pureScale in version 12.1. And then we're going to take a look at pureScale on AWS and some sneak peeks as well. So if you want to click here, then we'll probably get, yep, and some sneak peeks. Excellent. And we'll look at the new administration tool. So let's get into history of pureScale. So for those of you who have strong links on the mainframe, you almost certainly know about Sysplex and DB2 pureScale, which I first encountered as a super secret project inside IBM called Coral, which was so secret at the time that actually we segregated the development team. So the people who were working on Coral were not allowed to speak to it about anybody. So it was, yes, completely sort of closed shop. But it is a game changer for Linux to have this sort of technology on it. Much of the design is a straight lift of the capabilities from Sysplex, and we've extended it over the years. But the original sources we're working with were machine translated from DB2ZOS. When we started, it was an RDMA only offering. Internally, we had TCP/IP support up and running earlier because we needed it for development purposes. But when it went out to customers in DB2 version 9.8, which was a pureScale only major release, it was entirely RDMA only, and initially entirely on AAX. Linux came along later. Now, when we built pureScale, it was tightly tied to some of the decisions made very early on. So the cluster automation, which is the section of the product which reacts to system problems, be it software, be it networking, be it disk, was all very tightly tied to RSDT and TSA technologies. So anyway, let's look at the architecture diagram. It sounds like a good half the people who are here are very familiar with this, but there's some important pieces. DB2 PureScale is built so that the clients still are really just connecting to a database. So from the top of this diagram, the key things are the clients don't need to know what parts of PureScale are up or down. They have a connection, and the connection is managed for them. That connection management is handled by workload balancing, and there are a few controls we offer to sort of allow you to move connections away from members when you're going into maintenance. So that's the sort of application tier view. When we look at the pieces of a PureScale cluster, there are the members, and that's basically the database engine. So PureScale is a scale-out technology. Each of these members can work independently, or mostly independently, and each of them has a direct link to the shared storage underneath. So every database member has access to the same data at all times. Now, in a database which is working entirely sort of with data off disk, that would actually create a huge amount of contention. So PureScale technology brings basically the cluster facility to the picture so that we can actually be more nimble and more sort of lower contention, lower latency on all the operations. So the clustering facility brings in a lock manager at a global level, so a cluster level lock manager. It brings in a global buffer pool, which is a tier 2 buffer pool. Each member has his own local buffer pool, but then for pages not found in the local buffer pool, the first request is made to the global buffer pool. And the assumption here is it is far faster to get the page over the network than it is to get it off disk. And today that concept has been borne out many times over. So if we're doing all this communication of lock and page and a number of other aspects of the system between the members and the CF, the speed, in fact, the duration it takes to get the message to the cluster facility and back is critical. And so a dedicated TCP/IP network can get down to sort of sub 100 microsecond latency on a round trip. An RDMA network, and these days that's mostly RDMA over converged Ethernet, can get down to 20 microseconds, and in some cases even better than that. So the choice of interconnect between member and primary CF is a substantial factor in the performance of the whole solution. We have a secondary CF. The secondary CF is there to provide us with some redundancy. If we lose our primary CF due to hardware failure, heaven forbid, software bug, then we have an immediate ability to react and pull the secondary CF in. The secondary CF has all the buffer pool pages from the primary CF. It also has exactly the same lock state as the primary CF. So it can immediately, and by immediate I mean within 4 seconds, take over all of the activities that were on the primary CF, and hopefully from the user's perspective, they don't see anything. There's no interruption to operation. There's no strange SQL code flowing through the system. Now, in PureScale on Pacemaker, we are using majority quorum. So if you are on a system like this with an even number of members, then we need an additional resource which helps us break quorum. If we keep quorum, in the case we get a network split, breaking the cluster exactly in two. So that is something you won't have seen in PureScale with TSA when you had an even number of hosts. And we'll get into the details of what that tiebreaker host looks like. It's a very lightweight addition to the system. It can also be a part of multiple clusters. It doesn't have to be unique to this system. Anyway, so that's the sort of high-level view of PureScale. Let's go on to the next slide. So let's look at the new. So yeah, why are we going with Pacemaker? We've had a long history with TSA. TSA used to be an IBM product. It was actively developed alongside RSTT. It was, we had a great partnership when we started out the DB2 PureScale engagement. And actually, to be honest, both PureScale and TSA benefited greatly from a really extensive amount of testing. But TSA is no longer owned by IBM, it's owned by another company. And TSA has stopped developing. Sort of basically, its feature set is somewhat fixed now. And the only changes we're seeing are support for new operating systems, so RHEL 9, AX 7.3, but there's not any sort of functional change going on. So we looked around 6-7 years ago to try and identify candidates for a cluster manager which would allow us to embrace a lot of the new technologies going on. And the number one driver of our requirements was it had to be cloud ready. We had to have a solution which was going to be effective in the cloud, quick to go to cloud, would not pose sort of substantial challenges in adopting new environments quickly. And so there are not actually that many cluster managers out there which are suitable for what we need. Conveniently though, Red Hat and SUSE have been working for 14, 15 years now on basically a heart beating system, which is CoreSync, which allows us to track the membership of what's in the cluster at a networking layer, and then Pacemaker, which is a monitoring and dependency configurable layer on top of CoreSync, which can understand the state of the system through the idea of resource agents, which can start, stop, or monitor parts of the system. And those resource agents are very flexible. They are basically, there's a set of requirements, you can write your own, and it allows us to move very quickly. Pacemaker also supports fencing, and fencing is actually the act of taking a system down in such a way that it cannot interfere with the rest of the cluster. Fencing is an area where there are many different potential backends, depending on where you are. If you're on a physical machine, you might talk to the base mode management controller. If you're on a cloud provider, there are going to be cloud-specific requirements. And so when we looked at the Pacemaker universe, we realized that all the places we needed to go were already supported. And it's an open source project. Open source projects are driven by need, and they are driven by the community. And all of those aspects together made Pacemaker a very clear choice to us. It was supported by an active community of over 100 contributors. It had the backing of major Linux vendors. It also had a proven track record. It's not just us in this particular picture. Okay, let's click through. And yes, when we decided that we were going to go ahead with Pacemaker on Linux, yes, we made a deprecation statement about TSA, and TSA is not bundled with DB2 on Linux in v12.1 and later Modpack. It is bundled with AX, and I'll get to the AX picture later. So yeah, I've started to talk about some of the aspects you see here. So those are some takeaways I want to make sure that people are aware of. When we look at TSA and RSTT, the mapping is very clear. The TSA maps pretty much directly to Pacemaker, and RSTT, which is the sort of networking heart beating part of the cluster ownership, maps very directly to CoreSync. There are many advantages to being part of an open source community, one of which is the ability to inspect the code and really understand the design. We never had that when we were talking to even to the TSA team. We've also brought a lot of the technical support in-house. So We have obviously people on our team who are responsible for building and packaging Pacemaker. We have people on our team who are getting into the code and looking to see where we can expand on Pacemaker and CoreSync. So we have active development interest in there. That also means that our support stack is entirely within IBM. And that is a huge advantage for us, and hopefully a huge advantage for user. And one thing which I think is hard to overstate, TSA was huge, is huge. It came with the full Java stack installed. I think out of the install image, something like 400 megabytes was actually the TSA infrastructure. Pacemaker is not anything like that scale. And to be honest, that sort of simplicity and sort of fitness to one purpose actually suits us down to the ground. So let's move on. So yeah, I've talked about TSA development not really moving forward. And yeah, we have a strong backing from the Linux vendors. We don't yet support pureScale on Ubuntu, so please don't get too excited when you see Ubuntu in this list, but Ubuntu is another of the Linux vendors who are interested in this technology. And there has been a sort of consolidation behind the Pacemaker technology. A lot of the competing small projects which are around in the open source community in this area have either sort of lost developers or lost interest. Pacemaker continues to see a very steady development roadmap and contributions from the community. So we're very confident about where we are. And yeah, Pacemaker is cloud ready basically straight out of the community. And we can see support on AWS and Azure today. We have support for Google's cloud platform, and we have IBM cloud support as well. So we have covered our principal cloud vendors today. And when it comes to pureScale, we're a little more selective than this list, but from a Pacemaker perspective, it covers all the places we've been asked to go. Let's move forward. So you've seen this architecture diagram a few slides back, but I want to dig into how this breaks down from a Pacemaker perspective. So I talked about the members. The members connect to the cluster facility through the network. We have the cluster facilities, and there's two of them, and then we have mounts onto the disks. Those are critical resources in the system. In the case of something like the member or the CF, those are represented by software processes. In the case of network interfaces, those are kernel level devices, the same with mount, file system level devices. And then we have concepts beyond that, which are critical to the operation of a pureScale cluster. Fencing is the ability to cut off a member when it can't be considered as part of the cluster anymore, usually for reasons of network split. The instance is the concept of what you start or stop at an instance level in pureScale. So you can start and stop a member, but you can also start and stop the instance. So that's another thing we need to monitor. Another key piece in the pureScale infrastructure is where are the lock requests going? Are lock requests all going to the primary CF? So we need to know where the CF primary is. And another key piece of the picture for pureScale is how do we recover quickly in the event of a failure? Say we lost member one. When member one goes down, we need to very quickly turn around, detect that member one is gone, and then we need to do restart light processing. Restart light processing is handled by idle resources. Those are DB2 marked as idle. Those idle resources get activated in the case of a critical failure, and we move the sort of crash recovery phase over to the idle resource to get any locks which were in flight from the lost member back into the system and get basically as close to seamless a recovery as possible. We just click once here. We should get the actual monitors we're using. So Pacemaker has resource agents. We've built each of these resource agents specifically for pureScale. In a lot of cases, they build strongly, and in some cases, sort of an almost exact match to the resource agents we've built for HADR and actually for the other highly available solutions we offer, mutual failover and DPF high availability, all feature in DB2 version 12.1. So you can see there is pretty much a one-to-one mapping between the resources we have to be aware of on the right and the resource agents on the left. When it comes to comparing the resource agents here to the resource agents from HADR, the ones which are new are going to be the DB2CF and DB2CF primary roles, the DB2 idle roles for recovery, and the mount and fence operations are specific to pureScale here. So these are specifically built for pureScale capabilities. Fencing with Pacemaker is a general concept. We had fencing in version 11.5 with pureScale. We've had it since the start. The fencing we're using here is exactly the same fencing as we have always used. It's fencing driven at the file system level through IBM storage scale, also known as GPFS. So while we have put basically a monitor on top of the fencing, the actual fencing operation itself is exactly what we've had before. So one of the things I do want people to take away as we go through this presentation is that while Pacemaker is new, there's been a huge amount of work to make sure that we are building our Pacemaker model firmly on over a decade of experience with pureScale, that we are leveraging technologies we know to work well and reliably. And we have also made good use of the knowledge we built up from our HADR and other highly available offerings. And all of that has been put together to make pureScale with Pacemaker hopefully as robust or possibly more robust than we ever had with TSA. Okay, let's move on. So a lot of getting up and running with pureScale is hopefully well documented. We've had dramatically reworked a lot of the documentation in version 12.1. It's been a huge challenge, and my hat's off to the development team and the communications team for getting so much work done. There are probably still some rough edges. We're working constantly to go through and basically ensure that everything is as clear and as well laid out as possible. So if there are areas in the documentation where you go, hang on, I don't understand this, please let us know. We are absolutely looking at the documentation with a razor focus, trying to ensure that they are as clear as possible. So one of the things you will find in the documentation is DB2 Prereq check. This is a standard getting up and running with pureScale requirements. And the command is basically unchanged from what you would have had for 11.5, with the exception of the version number. When you run it, it'll tell you all the bits and pieces that you need to get installed on the system, and all the requirements needed for Pacemaker automatically set up. So when you see the DB2 Prereq PCMK, hopefully nothing extra needed here. Go on to the next slide. I've already mentioned that TSA packages are gone from the install image. So the packages are gone. The installer, which actually installed the packages, is gone. So the install image is, I think, 400 megabytes, or give or take, smaller than it used to be. The commands you need to install pureScale with Pacemaker are exactly the same as we had previously. So DB2 install, you can do a GUI install via DB2 setup, or there are also silent install options. But hopefully, at this point, very much unchanged. So running DB2 install, accept the license, please. We're always going to be server for pureScale. Hopefully, you're enabling the pureScale feature, and it'll run through and give you the list of tasks. And that should be it. Again, no change here at the DB2 install level when going to Pacemaker. Under the covers, we're going to install the resource agents that I talked about a couple of slides ago. we will have installed the RPMs for Pacemaker. Those are bundled as part of the install image. Each of the RPMs are tagged with DB2 PCMK so that they can be clearly identified where they came from. Okay, let's move on. Yeah, and the bits which call out Pacemaker being installed, yes, it says 100 seconds. I've never seen it take 100 seconds. It's usually 15 to 20. When we move on to instance creation, so we've installed the software, now we're going to create an instance. Again, this should look very familiar to anyone who's done a pureScale install. You specify the list of members, you specify the list of network adapters that are going to be used here. These are all Rocky adapters. The instance shared home is specified, and yes, away we go. Click once. Yeah, there we go. So under the covers, DB2 Create is going to go away and install Pacemaker on all the systems which I mentioned. If you go and look through the RPM list, you should be able to find the Pacemaker installation. 217 is, I think, what we shipped in 12.1.0. I think we're now going to be at 12.1.8 or 12.1.9 in the next mod pack. Should be in your hands in the next quarter. When you look down in the database management configuration, you should see that the cluster manager has changed from TSA and is now reading as Pacemaker. So if you're used to seeing TSA in this particular section of the DBM config, now it's going to say Pacemaker. Click once more, we should get that highlighted. There we go. Okay, next slide. So once you've done a pureScale installation and you've done an instance create, capacity needs change over time. The ability to add or drop members out of the pureScale cluster has been a key part of the offering since very early in the 9.8 series. The procedure here is unchanged. Whatever you have done in the past to add resources, it's going to basically be exactly the same command in v12.1, even though underneath the covers, we now got extra Pacemaker installation. Out of all of the topology change operations, only drop member is an offline operation. We do not yet have drop member as an online operation. It's a much requested feature. It is something we are actively working on. It turns out to be an incredibly complicated business to get right. And I meet fairly regularly to see where we are. So this is definitely something we want to address in future releases. Precisely where it lands is going to depend on how confident we are that we've got it 100%. So today you can online add a member. You need more capacity, away you go. If you need to change your CFs, say you're changing hardware, you can drop a CF, add a new CF on a new piece of hardware, and move forward. All of those operations can be done online. If you need to reduce the size of your number of members, to drop from 4 members to 3 members, I'm afraid that's an offline operation, and I think there's a backup requirement as well. So hopefully, in the not too distant future, we will have all online, but it's not there today. Okay, let's click once, get the highlights. Yeah, so Pacemaker's installed automatically underneath the covers. And let's move on. The ability to maintain a cluster while maintaining availability has been a key part of many customers going to pureScale. So in 11.5 and earlier releases, we had a utility called DB2 Cluster. That was a pureScale specific utility, and it was built specifically for pureScale operations. Now, all of the pureScale commands that you need to manage the system have been brought over to the new DB2CM utility. The DB2CM utility is our go-to utility for all Pacemaker-related operations. So this ranges from listing the configuration, showing the status, managing the file systems, going into maintenance mode. All of these things are now run through DB2CM. DB2CM knows when you're on a pureScale system and will only expose the commands which are suitable for pureScale operation. Entering maintenance is exactly the same with DB2CM as it was with DB2 Cluster. So you enter the Cluster Manager maintenance first, you then enter file system maintenance, you do whatever operating system updates are needed or security patches or whatever. You can reboot under maintenance, no problems to the rest of the operation of the system. And then to exit maintenance, you leave cluster management exit first, you leave file system maintenance next, and then back up and running. Restart the instance on the host, and away we go on the member. So this is hopefully familiar, but just DB2 Cluster to DB2CM. So far I've really been talking about new installations on with pureScale on version 12.1. I suspect the majority of users will get to 12.1 having had an 11.5 cluster up and running. So the upgrade from TSA to Pacemaker, this is an area we spent substantial time thinking about. How is this going to look? And ultimately, we were driven by it had to be easy. It had to be seamless. It had to give you a fully working system out of the box. It had to handle all of the changing from TSA to Pacemaker under the covers. And it had to basically use mechanisms we were confident in. So removing TSA packages, no problems. Installing Pacemaker, it's exactly the same mechanisms we use for the regular installation. Also when we extend the cluster. When it came to how do we set up Pacemaker and know that you have got everything that you had with TSA? Well, when we have a pureScale system built with TSA, every time you add a mount, add a part of the system, we have a registry. This is the registry we go to if you do DB2 cluster -repair -resources on an existing pureScale TSA system. So we had a mechanism which we trusted and had lots of confidence in, which would allow us to basically follow exactly the same model. So building the Pacemaker resource model from the 11.5 metadata is actually exactly the same operations as if you were adding them new. That's all common code paths. Very confident that this will work for everybody who has a system where it is entirely tied to the pureScale offering in 11.5. If you have customization on top of TSA, that is where we will need to talk more in detail, because those customizations are not represented in the HA resource model, and we will have to have probably documented solutions on how to address. So if you put CDC in your resource model for TSA or something similar, then we need to talk about how best to sort of put those into a Pacemaker model. If you're interested in how to extend Pacemaker right now, there's actually a set of 6 blogs, I think it is, which are called the Book of Pacemaker. They were published on the IDUG site. They were also published on the IBM.com community. If you can't find them, I'm sure I can make them available to you. The links are should be searchable. Google, whatever your favorite search engine is. Okay, let's move forward. If we're upgrading an instance, this is basically the same procedure as you would have taken to go from 11.1 to 11.5. You basically put the cluster into full stop, so you stop the instance fully. And this is an offline upgrade. Sorry, we don't yet do online upgrades from major versions. It's much requested. We aren't there yet. So go through, do the prereq check, do the install on all hosts, exit maintenance, start the instance, and then drive the DB2I upgrade process for the instance. That should be it. We're going to migrate the RSC to T domain under the covers. We're going to verify that everything's up. And then, yes, when you do db2 get dbm config, you should see the cluster manager is Pacemaker. And hopefully, that's the sort of all of the bits and pieces of PureScale you know and love are going to be pretty familiar after that. Yes, we've changed from DB2 Cluster to DB2 CM. The DB2 instance list is unchanged. A lot of the operation is unchanged. We're trying to make this as transparent as possible. Okay, let's move on. Rolling update. Again, this procedure is very much unchanged. It's likely that some people are very comfortable with the auto update. I think if you're in sort of dev test, auto update is probably a major time saver. If you're production, I know most of the customers I speak to, they handle their rolling updates on production on a one host by one host basis. That's okay. It's whatever your comfort level is. But automatic update can actually do multiple members and CFs in parallel. So it can be much more convenient to use that approach. But yes, it's where is your comfort level. Yeah, and so DB2 update, verify the database at the new level, and away we go. So that's rolling update. Again, pretty much unchanged. Next slide. So yeah, all of the Pacemaker changes will be applied underneath the covers. So if we are bumping the Pacemaker version, it'll be automatically upgraded through the RPM system underneath the covers. Okay, next slide. So PureScale on AWS. This debuted, what was it, July 2023. So we've now had a couple of years of experience with PureScale on AWS. Go forwards. So we've updated the AWS offering. If you go to the marketplace on Amazon, and if you don't know where it is, if you type AWS Marketplace PureScale into your search engine, it should be the first link. Always has been so far. Originally, and I think I discussed this with various people at iDoug, we were originally going to just have V12.1 available through the AWS Marketplace. For now, we're taking you can try V12.1 out, or you can do 11.5.9. Again, this comes down to sort of discussions we've had with customers. Not everybody wanted to be forced onto V12.1.0.0. So right now, we have V12.1 Modpack 1 available on AWS and 11.5.9. Once you've got your system up and running on AWS, it is essentially yours. So whatever you need to do in terms of maintenance is handled exactly the same as on-prem. If you want to move from a 11.5.9 installation on AWS to V12.1, it's an offline upgrade, much as I've detailed here. So we have a larger list of clouds than just AWS. PureScale on Azure was the next most requested solution. So we have particularly customers in Europe who are very interested in Azure. For some customers, they are getting directives from their C-suite. It's like all of the solutions are going to be on one cloud provider. So AWS is very much just the first step. That was us getting comfortable with cloud deployment, what a cloud solution might look like, where we would have to find variance with what we do on-prem. Thankfully, not very much. And Azure supports TCP/IP, which is what AWS supports for interconnect between the members and CF. But excitingly, Azure supports RDMA also. And the RDMA that Azure offers is basically familiar Rocky. So that made it very easy for us to go in and get RDMA up and running on Azure. And thank you to the teams who've spent time testing, building template systems. We now have DB2 PureScale on Azure available. Reach out to us if you're interested. It should be up on the Azure Marketplace. It has the same sort of automated deployment that you have on AWS. So on AWS, it's about 40 minutes to deploy. I think on pureScale on Azure, it's about 35 minutes to deploy. So you can have a pureScale system up and running on an AWS or Azure within an hour and be building your first database. On AWS today, we have a number of automations which are available, which are intended to make life easier around changing disk storage, adding a member. We don't have those yet on Azure, so they're work in progress. Once we have built out the systems, they'll be added to the Azure platform as well. And so, yeah, this is available now. Very exciting. And we have already a number of customers who are lining up on this. So pureScale on cloud, AWS and Azure, it probably won't stop there, but that's where we are right now. Okay, let's go look at DB2CM. So when we started out on the Pacemaker journey, DB2CM is a bash script in 11.5. And bash is very useful because it's very quick, very easy to get stuff up and running. It's very easy to put a new version out very quickly. No compiling needed. It was convenient, but there are limitations with shell scripts, particularly limitations with shell scripts when you're trying to do privilege management and security management. There are a lot of reasons to go and basically use a full executable. So in the V12.1 planning, we knew we had to get DB2CM from a bash script to a C++ executable. This allows us to share infrastructure with the rest of the DB2 engine. It's the same for all the highly available solutions, so HADR as well. So now we have a lot of common code. Previously, we had DB2 Haiku and DB2 Cluster as two separate, very different design approaches to managing a highly available solution. Everything now is under one roof and one utility. This also allows us to introduce a new security model in V12.1. One of the challenges with running the DB2CM bash script, a lot of the operations had to be run as a root user, and that caused all sorts of challenges for a number of customers, not just in terms of security exemptions, but trying to build pseudo lists and other complications. Anyway, let's move forward and get into DB2CM. The security model is important. We need to be able to administer systems. We need to give the right level of privilege to the right people. So the security model for DB2CM has really two main focuses. One is the system administrator, and one is the cluster administrator. Let's move forward. So the system administrator is really the person who's looking after the cluster, not the database. So root user, or any user who's authorized to run as root, but they're not interested in the data, they're interested in the cluster, the pieces that make up the cluster. It's about installation, configuration of cluster services, it's about maintenance, and it's also about the shared file system. So it's all of those jobs which affect the cluster as a whole, and that's often spanning multiple hosts in the cluster domain. Moving on. So we talked about rolling updates. We talked about sort of host by host maintenance. All of those things are handled by the system administrator, and making changes to the cluster manager. So there's the commit option in there. If you're creating or deleting domains, so there's what I think of as sort of primary setup. Those are also under the expected roles that a system administrator might need to be able to sort of apply. So The only caveat here when you're running as root is you might not have the environment that is set up for the DB2 instance user. So to handle some cluster administrative commands, you need to set the DB2 instance environment variable to the appropriate DB2 instance host. And remember, on pureScale, there's only one instance allowed on the system. The cluster administrator is much more about looking at the state of the database, looking at the state of the resources, importing and exporting resources, handling sort of resource management. The cluster administrator also has the ability to repair the cluster resource model. Not that we've needed that so far, so our stability has been excellent. The system administrator can also perform cluster administrator tasks, and the ones which do not require access to the actual data. So out of the box, we grant the cluster administrative privileges to the instance owner. So if you're DB2 inst1 or DB2 sdin1, that's the user which will be given the cluster administrative privileges. So you will then be able to run things like db2cm-list, which previously you needed root or sudo access. Now you can just see the state of the resource model at any time from the instance owner account. And that instance owner user is, for pureScale and also for DPFHA, available on all the hosts in the cluster. One of the reasons we had so many challenges around root user was CRM shell sets up, so CRM shell is a Python-based utility which we leveraged in the 11.5 series to help us with the cluster administration. But it came with restrictions, which basically meant it was almost always run as root user, and therefore it tied almost everything we did to the root shell. So when we've moved to the DB2CM executable, we've also removed all of our usage of the CRM shell itself, and we no longer bundle CRM shell with DB2LUW. It should be unused by version 12.1. So this is, again, allowed us to sort of do things with the security model, which we think substantially more focused about who needs to do what on the system. A critical area for cluster administration is the DB2 instance list. This tells you what state all the parts of the system are in. Are they in a good state? Are they on the host they were intended to be on? The home host is where you expect the hosts to be. Are there any alerts in the system? And if there were alerts here, there would be instructions on what to do next. This command is basically unchanged for version 12.1. It should work exactly as it always has done. The alerts may now tell you to do things using DB2CM rather than DB2 Cluster, but otherwise the output is going to look very, very familiar. DB2CM list is basically a view down onto the state of the system. Some of the information you see here is going to be very similar to that you've seen in DB2 instance list. We obviously have additional information about the software which is installed here. The domain leader in this output actually tells you which host in the Pacemaker cluster is responsible for making decisions. So here the domain leader is basically PSServe2. There's 4 nodes in the system, and everything appears to be online. If we click 2 more times, we'll see some more information. This is quite a wordy set of outputs. So you can see we're using fencing, and the DB2 Fence PS resource agent is the one responsible for that. We're using majority type quorum here, and the resource information about what's online are, you would expect all of the resources which are in good state to be in managed state. So managed is true for all of these bits and pieces. And you can see here we've got CFs and we've got the primary role, and this goes on across all of the hosts and roles in the system. Let's move to the next slide. Another key part of keeping a cluster healthy is knowing that at any time you can check that topology is in good shape, is the file system configured correctly, is SSH working, is the performance of RDMA, is RDMA working, because that tends to be more difficult to check with additional tools. If this was an RDMA cluster, then we would obviously not have skipped here. If we were using DB2 SSH, then that would also be verified here. So DB2 Cluster-Verify has become DB2 CM-Verify. And that's really the sort of only substantial change, is the name of the utility. So, yeah, obviously these days it's RDMA Rocky everywhere. Yeah, and if you're using DB2 Lock SSH down at the bottom. Another area where we've been hopefully making good use of the muscle memory you've built up over the DB2 cluster years. Every one of the CFS commands is exactly the same with DB2 CM. So again, this sort of feeds into the, we're trying to make things consistent. We're trying to make sure that you're working in a familiar environment. All of these are basically unchanged. Next slide. Yeah. So we GA'd this, goodness, last year. End of last year. We have a lot of mod packs going on. Mod pack 1 was focused really on sort of driving the quality assurance even higher. That obviously leads into more bugs fixed, which is always good. So yeah, let's look at some of the items under sort of development going forward. So I mentioned that Azure had RDMA available and we could use it immediately, and we have. In our offering, you can immediately use RDMA on Azure. AWS doesn't offer RDMA in the same easy to pick up, at least from our perspective, solution. Amazon's solution for RDMA operations between EC2 instances is Elastic Fabric Adapter. Elastic Fabric Adapter version 2 is their current high-performance solution. I hear that there's a version 3 in the works. It may not come to Intel-based systems for a while. We'll have to see how that goes. But the bottom line here is we can't just put pureScale on an EFA system and have it work. The design of EFA is subtly different from standard RDMA over converged Ethernet. And so we actually had active development work here to try and get this up and running. You should see an EFA capable pureScale in the not too distant future, definitely this year. It's important that we have an AWS offering which leverages EFA, because we need to do as much as possible to minimize the length of time it takes to communicate between the members and the CFs. So we're always chasing the shortest lock times. Page invalidation, that's where one member makes a change to a page. Say you've done an update on a row. The other members need to know that their copy of that page, if they have it, is not valid anymore. So that's what page invalidation is for. Make sure that we always have the right data in front of all of the members. Yeah, and so anything we do around adopting RDMA technologies on AWS should reduce contention between members, and therefore you can get more transactions done faster. Replication. TDC or QRep, it's an area where a lot of users want to have another copy of their data outside of a pureScale cluster. These sorts of logical solutions basically have some requirements to communicate with an active member. So we will probably have documented solutions in this space before we sort of go anywhere near an integrated solution. And I think it'll be very interesting to see what sort of conversations we have with customers and users around this. So we actually sort of focus in on the exact needs. TDC and QRep are documented for, say, HADR with TSA on the publicly available HADR wiki. We're looking to get similar sort of documentation up for Pacemaker. And yeah, the key things here is we want to make sure that people can hook these sorts of solutions into their pureScale environment and have confidence in them. Move forward. Online drop member. Yeah, I teased this earlier. It is coming. It's just a question of precisely when we're happy with it. Online drop member will get us to the point where we properly support elastic topology for pureScale. When I think of cloud, the idea of being able to scale up or down a member and then being able to scale out and back a cluster, that sort of fully embraces the sort of flexibility that cloud deployments bring, and the ability to basically remove cost off a pureScale cluster by removing an entire member out of the system is, I think, a great way of sort of managing one of the sort of challenges with cloud, which is keeping costs under control. There's another key area where online drop member is going to be incredibly useful. If you've ever had a pureScale cluster where a motherboard has failed on a system, yeah, that's a really ugly situation. So online drop member will allow us to basically isolate and remove a completely failed part of the system. And if you have that happen today, it's definitely support time. Okay, let's move forward. Online index rebuild. Yeah, up till now, we've had reclaim extent and cleanup for reorging, but rebuild is coming. So all those dreaded 1419N SQL codes should be a thing of the past. So that's another exciting thing to be coming forward. I think we're almost at the end. Yeah, there we go.
Awesome. Oh, thank you. Thanks, Toby. I think I have a question about the quorum. Remember we have with the existing pureScale with TSA, the quorum problem, what we have with RSCT, having more than 8 members is going to create a problem. So do we have that limitation with Pacemaker as well, or is uplifted?
So the limitation with quorum in pureScale today is actually a IBM storage scale limitation.
Oh.
So the same limitation there applies to pureScale with Pacemaker as well. And just to sort of fill in a little bit of the blanks, GPFS supports very large clusters, but only 8 hosts in a GPFS cluster can actually participate in quorum.
Right.
So yeah, we're always looking to see what we can do better there, but yeah, that limitation still remains today.
Great. Let me see if there are any other questions now. Couple of questions. One is about the algorithm, what we're going to be using with pureScale. I think with the Pacemaker clustering, it's going to be majority. When it comes to HADR, there are 2 algorithms which it does, the last man standing and 50-50, and this algorithm is the majority algorithm, right?
Yeah.
Okay.
So yeah, and we have been building up our experience with QDevice, and that's our recommended solution for an even number of hosts.
Right.
QDevice is a cryptographically signed service that participates in quorum votes when you get into a situation where, say, you have a network split and you need to decide which half of your cluster, whether it's an HADR single host or half of a pureScale cluster, will sort of remain with quorum and the other half will be basically forced out. So that's where we get into Stonist technologies.
Right.
And removing the half of the cluster that is not participating in quorum. QDevice doesn't need very much. It needs like a couple of CPUs. It needs a little bit of memory. A single quorum QDevice can actually handle multiple clusters as well. So while we accept that that's an additional host requirement today for an even number of members on a pureScale cluster, it is a much more robust solution. We are looking at trying to sort of match the technology we had with TSA had a tiebreaker disk system, which allowed you to have an even number of members and use a shared storage resource to resolve quorum. We are investigating whether we might sort of provide a similar offering on top of it won't be on top of Pacemaker, it will be on top of CoroSync.
Okay.
So that's working sort of discussion, let's put it there. But we are aware of trying to have that sort of level of parity as well.
Great. Thank you. All right. I think we are at the end. Thanks, Toby, for all your insightful, full-packed presentation today, and appreciate your help and appreciate your time. And I saw an email. Sorry, the chat coming? No. All right. Today's sponsor, DBI Software, a partner for helping you with performance benefit for the databases, preferably or primarily DB2 and SQL Server. And this is one of the dashboard you can see when you launch with our flagship product. And it is going to give you a lot of information about worst performing, best performing, and the highest transaction rate and all that in one single dashboard. All right, with that, I think we're going to close the call today. Again, Toby, thank you very much, and we'll be in touch.
Thank you very much.
Have a good day, everybody. Take care.
Thank you.